Okay, anyway, it's time to start. We are missing the first presenter, but hopefully he'll be able to join us later. So again, I would like to welcome you all to this session. The title is Advanced Visualization. Yes, this is obviously a very broad area, because if we see the papers are dispersed in several areas. The first paper focusing is on virtual reality, on geometry aspects of modeling of geometry. I think the focus of the second paper that will be presented by Mr. Brinkmann is on two areas: how to visualize design process maturity and augmented reality aspect of visualization. And then Ms. Bravo will present again something that is focused on augmented reality, applied to presentations on team meetings. Then we have a slightly different focus, more theoretically, I would say. The fourth paper that will be presented by Mr. Pottebaum is interesting. I think it opens a new area, a very interesting area, because it analyzes the morphology of a connection between abstract models and visualization techniques. And finally, the paper that will be presented by Professor Stadler is, I think, the focus is on graph-based design languages, and somehow this is the area, I think, of computational design synthesis. Anyway, I hope that we will manage to develop fruitful and interesting discussion. Just a few sentences for introduction and the procedure, although I think that you are already familiar with that. So firstly, we will go through all 5 videos. Then we will start discussion until the end of the session. I think that's enough for introduction. Prior to videos, I would like just read short biographies of presenters. Mr. Stadler, the presenter of the first paper, graduated from the Department of Industrial Design of the Technical University of Munich. He gained working experience in BMW, Bosch, and several other companies. So, Fanika, please, can we start with the first presentation?
I would like to welcome everyone to my presentation with the title IMPRO, Immersive Prototyping in Virtual Environments for Industrial Designers. My name is Sebastian Stadler. I work at TUM Create, a research institute in Singapore, and this paper was created in collaboration with my colleagues Henriette, Cornet, Damien, Mazeas, Jean-Rémy, Chardonnet, and Fritz, Frenkler. Due to the time restriction, I will directly jump into the introduction, followed by the method of this study, and then I will come to the results and lastly point out some limitations and an outlook. The introduction. Industrial designers since ever work with pen and paper. They draw, they sketch, they visualize their ideas. In the 90s, digital equipment was added to the toolbar of the designers, which is, for example, CAD applications, and lately also immersive virtual environment is added for these investigations, and therefore we created an application for immersive prototyping and tested how it works compared to other VR applications as well as to desktop CAD applications. For the methods, here is an overview of the different kind of methods that we use. Firstly, we made an analysis of commercially available VR applications. Here it is Google Blocks, Microsoft Maquette, and Mindesk. Furthermore, we conducted a user evaluation test of these commercial VR applications in which participants had to create a low complexity 3D volume, and we measured the time to complete the task, the functionality, as well as we conducted the system usability scale. Out of this, we derived design guidelines that helped us to develop our applications, and afterwards, of course, we underwent the same evaluations with our IMPRO application as well for the same as for the other applications, and to see how immersive CAD applications are compared to desktop-based applications. We also tested 2 applications that are desktop-based, and lastly made a rating of the model quality to derive how the different applications had an outcome. These are the different models that the participants had to recreate. Every participant had to recreate all of these models in each of the different applications. So they were all low complexity applications in which primitive volumes were arranged in a specific manner and therefore resulted in these different models. I directly jump into the results. Here you can see the time to complete the tasks. Overall, I would say that the VR-based and desktop-based applications all had a very similar average time in seconds, from 400 to 530 seconds, except IMPRO that was a little quicker, and Maquette that was slower than the average. Then in the functionality questionnaire, in which we asked for the ease of navigation, of modifying and interacting with the application, we had different scores that we derived, average functionality scores. Here you can see that also IMPRO is on the upper end of the applications, and overall that the desktop-based applications were better than the VR-based ones. For the system usability scale, here this is a standardized questionnaire. A average SUS score above 68 is considered as above average usability. Here IMPROVE also was among the best ones, and you can see that Google Blocks was also very good, and the other ones were average or below average. And lastly, we analyzed the quality of the model. Here we had 3 experts that looked at all the different models that were created and had 4 different categories, which was the amount of primitives used, then the correct tools for the object creation, the correct assembly and orientation of these primitives, and lastly the proportion. And here you can see that also the IMPRO was the best one, but also the Google Blocks as well as Rhinoceros were among the better ones. Here we'll come now to our limitations. We only had a sample size of 14 participants, so therefore the sample size should have been larger in a better study, in a bigger study. This is what we will do in the future. Then the comparability of models always is not sure, since they are not the same, of course, and the complexity of the task was very low. And for the outlooks, we want to improve the functionality and the accuracy of IMPROVE, and lastly tested in additional application fields. That's it from my side. Thank you very much for your attention. Thank you.
Okay, then we are going to the second presentation. This will be presented by Mr. Jens Thomas Brinkmann. His short CV: after receiving his German diploma in industrial engineering at the Clausthal University of Technology, Jens gained consulting experience in Santiago de Chile, Hanover in Germany, and Wolfsburg. Prior to the research at the University of Auckland, where he is now, he prepared and hosted virtual assembly meetings for Volkswagen.
Kia ora. Hello from New Zealand. My name is Jens Brinkmann, and today I'm presenting the publication that my PhD supervisor, David Wynn, and I co-authored. Before we are going into the rather lengthy title, let me provide you with some background information. This topic is more or less my entire PhD, and internally we refer to it as the end-to-end workflow. The idea is, based on our own observation, backed by literature, and from empirical findings that we achieved, that practitioners, especially in engineering design, are facing more and more situations where they have to deal with preliminary or immature information. We decided to use the term maturity to refer to something similar to fruit ripening on a plant. We discovered that maturity of preliminary design information isn't something that you can easily express as one metric. You can't state this CAD file's maturity is a 3 out of 5. We encountered various terms related to maturity and aligned them in a taxonomy. Our taxonomy is hierarchically structured. On top is maturity. There are several perspectives. There are facets and subfacets. In this publication, we've only shown 5 subfacets. Currently, we think maturity can be captured by 17 subfacets. So we tried to apply the taxonomy to our own work and to judge our own work's maturity. We found that this is quite a challenging task. Therefore, for practitioners in reality, we want to provide eliciting schemes that help them. The scale was initially just the 3 traffic light colors, and then we added 2 in-between categories. Now, let's assume that the practitioner has assessed the maturity of his CAD part. He has generated 17 or 5 values, and these have to be aggregated in a meaningful way. Given the time restrictions, I won't go into detail. For further details, please see the conference paper. But on a broad scale, we have compensating and non-compensating factors, and they have to be treated differently in order to create meaningful aggregation. Now let's assume we went through all these steps and we have created values about different parts' maturities. We want to use them. We identified 2 relevant use cases, the development of insights and the visualization. The development of insights is based on a logic tree where each part is assessed, infused in part with DSM input and its maturity, and a penalty score is calculated to determine if you should start working on this part or not. For the visualization, we decided to use augmented reality, AR. For that, we need some physical object to overlay our data. Based on another publication, we found the mule concept, which states that you oftentimes have an outdated product version that you incrementally enhance, and we're going to use that for our AR visualization. Now I'm going to show you a video of our concept demonstrator, and afterwards I'm happy to take questions. Thanks for your attention. See you. As the app is started, guidance to an initial pose is provided. CAD files are downloaded. Based on their maturity, traffic light colors are overlaid. Let's flip it over to get a better view. An additional overlay is toggled, and a table showing the priority scores computed as per our method is shown. This concludes how we want to support practitioners' communication and decision-making by actively considering maturity statuses. Ultimately, let's have a look at the publication's title again. We have seen that assessing is based on the shown taxonomy and its practical applications supported by eliciting schemes. Ways of aggregating maturity subfacets, especially compensating and non-compensating, were touched upon. And for the visualizing aspect, we have seen the logic tree-based approach and the AR application. All of this is targeted at the maturity of preliminary design information, with the goal to support collaborative design.
Okay, now we are going to the third paper. Before reading a CV of the presenter, I realized that I forgot to tell all the people in the audience, but I guess that everyone is already familiar with that. When we will start discussion, please enter your questions in chat. So Miss Andrea Bravo is a PhD fellow at Engineering System Design Group, the Technical University of Denmark. Her research focuses on presentation of data and information in immersive environments such as virtual reality, augmented reality, and tangible user interfaces. She has a background in visual design, UX, and cognitive science.
Hi, my name is Andrea Bravo. I'm a PhD student at DTU Engineering Systems Design, and I have co-authored this paper with Anja Maier on immersive visualizations in design using augmented reality for information presentation. So immersive visualizations are information artifacts that make use of engaging embodied analysis tools to support data understanding and decision making. And in this paper, we target the presentation of financial data in HoloLens. Concretely, we're talking about valuation data, which is data that estimates the value range of a company. Now, the paper has three aims. First, to identify presentation practices and challenges for decision support. Secondly, to identify opportunities for using immersive visualizations. And finally, to design and develop an immersive visualization for decision support. Now, the study has three phases. Phase one is about collecting data through interviews. So we did 7 interviews to data and business analysts, exploring first the presentation practices used, and secondly, the challenges as well as the opportunities. Our findings were the following. For information presentation practices, it's about fostering one simple and clear message, the use of self-explanatory visualizations with familiar technology, and usually the content display is static. The challenges are basically that data is decoupled from its context and the display of complex information. Now, some opportunities that we found for using immersive visualizations are the simultaneous perception and data and participants that can foster discussions and sometimes decisions, and interaction with the gradual presentation of information and real-time input and manipulation of. Now, the second phase of the study was about the design and development process. We did this together with a company in Copenhagen named VISUALISING, specialized in developing augmented and virtual reality solutions. So you can see here the second prototype of the visualization that we built, which are stacked bar charts. Now, the third phase consisted in a workshop in which participants had an initial training on how to use HoloLens, and individually they explored the data visualization. So after the exploration, we assessed individually each of them, and we held finally a collective review to have a general impression on the use of HoloLens to present valuation data. The findings for this workshop were basically that simultaneous perception of data and participants in the same space foster the discussion of the values presented. Also, the accessibility of information to non-data experts and interaction coupled to the presentation narrative, which directs the focus of attention. And this is one of the key findings, because if you can change the data alongside your discussion and put the input of these new numbers, you can actually visualize this information, and this can foster sense making around the table as well as support decisions. As a conclusion, we came to understand that the use of augmented reality in this type of presentations actually enables to maintain the attentions on participants and the data at the same time, because they're in the same field of view. And another part was about the dynamic discussion of values that I talked previously, which can assist decision support. Thank you. This research has been funded by DTU and H2020 Eureka project.
Professor, can I only ask you to unmute your microphone? Sorry.
Thank you. Thank you. Sorry. So the fourth paper will be presented by Mr. Jens Pottebaum. He's a senior researcher and lecturer at Paderborn University in Germany, Department for Mechanical Engineering. He studied mechanical engineering and computer science at Paderborn University. In 2011, he received a doctor's degree for his research on optimization of application-oriented learning by knowledge identification. His research deals with the application and applicability of information and communication technology for product creation.
Immersive abstraction, a new morphology of intuitive interaction with system models. My name is Jens Pottebaum. I'm working with Professor Iris Gräßler at Heinz-Nixdorf Institute at Paderborn University. What is our motivation? The value of models in product design applies across disciplines and domains. That's a clear assumption. At the same time, interconnected models are extremely large and hard to handle. So that means efforts for engineers, for designers. And we propose to combine the advantages of abstraction and of immersion. It seems like a contradiction, but we really believe that there is a value in bridging the two perspectives and the two communities. So our research question is, how can engineers immerse themselves in system models for more intuitive interaction? We have a demand in models like requirements models, process models, ontologies, their interconnection. And when analyzing literature, you can see that there are only very few approaches that are already trying to use the advantages of immersive technologies for this purpose. So we propose to bridge these two fields. So it is a kind of model transformation, task-oriented on the one hand side, which is the field of abstraction, and scene-oriented, which is the field of immersion. And to transform these two, we have to create a common ground, which for us is the morphology of intuitive interaction. And we are creating that as a cube, which is created by the I3 dimensions of virtual and mixed reality. First, there is interaction from viewing to parameterizing models. There is immersion with a scope on models or a scope on the actual product or system. And we have imagination, viewing or simulating simple models, complex models, or even augmenting models and, for example, real objects. And that's what we call the morphology for immersive abstraction. To bring that into one application case, we are using a case that we developed in our institute. You can find that application now as small building blocks within that morphology, within that cube. So the application case is about creating system models, about viewing them, and in fact, it is about complex models, diving deeper into that system structure. And it is also about augmenting a real object with the system model. So these are the small building blocks that you can find, and this is how you can perceive this morphology for immersive abstraction. Summing up, There are only very few approaches like this in literature regarding model-based systems engineering. We contribute this morphology of intuitive interaction for immersive abstraction. We focus on both applications and future research directions. So each of the building blocks includes options how to implement intuitive interaction. And at the same time, the cube presents a baseline for broader design research roadmap. Future research has to include both the empirical perspective and the constructive perspectives on creating options into that morphology. Many thanks for watching my presentation, and I'm really looking forward to these new experiences in Design 2020.
Finally, the fifth paper will be presented by Professor Ralf Stetter. He works at University of Applied Sciences in Ravensburg-Weingarten. His research is focused on models, strategies, methods, algorithms, and tools for the product development of all kinds of intelligent systems.
Ladies and gentlemen, our paper title is Abstract Physics Representation of a Balanced Two-Wheel Scooter in Graph-Based Languages. My name is Ralf Stetter, and my co-authors are Manuel Ramsaier and Markus Till from Ravensburg-Weingarten University in the south of Germany, and Stefan Rudolph from the University of Stuttgart a bit further in the north. I will talk about analysis and synthesis of abstract physics and what abstract physics is. I will talk about graph-based design languages. I will briefly explain our exemplary product development, which is a steering system for this balanced scooter. And I will explain shortly how abstract physics are integrated into the engineering framework, which is based on graph-based design languages. If we talk about abstract physics, it's good here on the left side to look at the levels of abstraction of a product. Very abstract are the requirements, what a product should do. Bit more concrete are the functions. And then in between the concrete product structure is a level which describes the effects and a bit more, and which we can refer to as abstract physics. Here we see three different views on abstract physics. One is phenomenon-oriented. This is mainly apparent in German design systematics, and there we have physical effects, effect change and effect networks, and to use these supports understanding and innovation. Very strong is the description of abstract physics on the behavior-oriented point of view. This is mainly mathematical. There we have linear and nonlinear equations. This enables mathematical descriptions and allows simulation optimization. It's really strong, but it does not cover the things that you find in the phenomenon. And yet another view is interface oriented. This was developed at the Karlsruhe Institute of Technology by Professor Albers and his assistants. It's called contact and connector approach, and this allows detailed analysis of effect surfaces and so on. And also that's another view that's also not represented. And if we want to represent this, we would like to have an integration in engineering frameworks. One possibility to realize such engineering frameworks are based on graph-based design languages. Here, the core is visible here. It's the Design Compiler 43. This compiler is able to compile a graph which also contains geometry. And therefore, it's also possible to derive cut data like step files, but also files for CATIA or Creo, FEM files, and so on. And in order to do so, the input data comes from a definition and programming based on ontologies, a vocabulary expressed in UML classes, structure in class diagrams, and a sequence of rules which is working with these class diagrams in UML activity diagrams. The example product is comparable to a Segway, so it's a balanced scooter, and we are looking here at the steering system. It's a system where someone is standing on this Segway and is pushing this lever to one or the other side, and with this is giving its the steering wish to the Segway. On this slide, you can see an abstract physics representation of the steering function of the scooter. I cannot go into detail here, but you can find the details in the paper. And the challenge was to represent this in the engineering framework, which is based on graph-based design languages. And one core of this integration was the integration in the class diagram. I can also not go into this in detail, but you can see that we have here integrated effects, which are arranged in effect networks, which are connected to actors in our systems. And these actors are connected to process of use cases. And we have use cases, and we have our system on consideration. We have other things which are also connected, like requirements. So through this integration, we can represent the abstract physics in a complete engineering framework. Obviously, this integration also covers the activity diagram, the rules, and the design graph, but due to time limitations, I cannot go into detail here. Thank you very much for your attention.
Professor, the mic again, sorry.
Thank you, Fanika. I forgot to unmute my mic. So we have heard all the presentations, and it's now time to start the discussion. Again, I would like to encourage all the present people in the audience to write their questions in chat. While we are waiting for questions from audience, I would like to start with some my questions. Firstly, I would like to ask Mr. Brinkmann, could you explain more in detail why you selected the augmented reality as a visualization tool? What were the other options why you choose this one?
Absolutely. So the other options are obviously that you would have the engineers who already collaborate using CAD software. So they could just stay within their familiar CAD packages. You can also think about having everything virtually, so VR instead of AR. Based on the experience that we gained, and especially in my last role at Volkswagen, where I hosted such virtual assembly meetings with people from different departments, engineers and non-engineers, we found that it's better to include not everything into the software set that is already given, like a CAD system. And based on this mule idea that was mentioned, where you have this outdated product version that you incrementally enhance or replace parts of which, it is probably better to push people out of these familiar CAD packages. Plus you have the possibility, because this app that we developed is running on a usual smartphone, that everybody, especially non-engineers, management, and other people who are able to provide valuable insights, can interact and can see in AR maturity statuses of different parts.
So basically, if I understood correctly, designers enter or assess the maturity through application on mobile phone. Did I understood that correctly?
You can also transport this eliciting, so the gathering of the maturity data to the smartphone. Currently, the idea is that you can do it paper-based and digitize it. You can do it in an Excel spreadsheet, that doesn't matter, but the visualization part of the current status of maturity that will be done on the smartphone in AR.
Okay, thank you. We have a question from Professor Maier to Jens Pottebaum. You mentioned system visualization modeled in SysML. What other system visualization might we envisage? Have you observed further ones being used in engineering practice?
So, thank you very much. Well, actually, we are mostly focusing on SysML. In that case, in general, our approach is focused on different kinds of abstract models, not only system models, but for example, well, ontologies, which are another case, and for which we have approaches of visualization languages that are on top of something like the web ontology language. Well, it depends, of course, on the type of system. So UML would be a similar approach for software systems. And in general, something that we are very much interested in is the linkage between these system models, for example, in SysML, and then the linkage to domain-specific languages, where we have, for example, geometric models from CAD, so having STL and VR at the end, or integration of STL files in VR scenes. So these kind of linkages are very interesting for us. In general, well, I guess the question of having observed that in industry is focused on the approach that we are describing. And in fact, we are describing results of a literature study where we see that there are only very few approaches that are doing that already. And actually the cases are, so they are all based on very few case studies applied in industries. But I cannot tell that this kind of visualization I could already observe in companies directly. Of course, in general, so speaking of SysML, for example, or other types, but I think this is not the focus of the contribution right now.
Okay, thank you. I would like to continue then with your paper, Mr. Pottebaum. I think that you opened a whole new area where really new research projects in various directions could further extend your work. I wonder if you can tell us your thoughts, how your proposal could facilitate teamwork and team communication, especially do you think that with that kind of bridges, the team could reach shared understanding more quickly than usually?
So that is definitely one of the motivating factors behind that work. And actually, this was the idea to structure this field as we saw different influences, and we wanted to analyze that and bring that into one contextual frame. And I would say Jens Brinkmann also contributed something which is already a very good example of integrating reality and an abstract model, in that case information about information maturity, but adding there different kinds of information of models would be very exciting. Building on top of that, the collaboration is of course another dimension. To add that and also to understand the effects of visualizing models in this kind of immersive way is something that we should well research. But I would say it is a two-step approach. One step is to make that possible and to make it possible in an intuitive way. So you have to transform models into a model that can be visualized in this kind of scenes. And then you have to add the functionality for collaboration, where there are a lot of opportunities in the field of virtual reality, and that would have to be added there.
Thank you. And Professor Maier posted the question to Jens Brinkmann. Could you elaborate on the quality of maturity? How might we calibrate for embedded assumptions in the formulation of maturity ratings? She refers on figure 3 in your paper. In other words, how might you arrive at the cell descriptions that are the base for assessment?
Okay, thanks for this question. I'm not sure if we're able to pull up the set figure 3, but if you might remember from the video, this was this eliciting scheme. So this is only one small fraction that we've shown in this publication. The idea is that you have, depending on each type of design information, so it might be a parameter value, which is quite simple. It might be a written document in prose, such as a design report or publishing. And then you might have a CAD file, which is more complex with the 3D CAD geometry. You have 3 different eliciting schemes for this example. And then you have basically as rows your 17 subfacets, which are all aspects of design maturity that we identified. And then you have this rating scale of initially 1 to 3, so your traffic light colors, and then 2 in between categories. So these 5 levels represent something similar to the confidence values mentioned in the signposting approach by Clarkson and Hamilton. And so that's the quality of maturity based on these 17 subfacets. And your specific question was, in other words, how might you arrive at the cell descriptions that are the base for the assessment? So these cell descriptions are our interpretation of what is important for these 3 types, meaning we thought about, if we were talking just about a parameter value, how does that apply versus a prose document versus a CAD file? So I hope this answered your question. Okay. Thanks.
Yeah, looks like it.
Thanks. Okay, I would like now to ask Ms. Bravo, can you clarify what do you mean by simultaneous perception of data and participant at meetings?
Yes, so precisely this is one of the points of using augmented reality with this immersive visualization that we have created. So we chose precisely augmented reality because in team settings, it allowed to see people in front of you, so the participants in the meeting, and it also allows at the same time to have the data overlaid to the environment. So this is one of the main qualities of augmented reality. I have also to say that we have used HoloLens because it enables more possibilities of interaction in comparison to using tablet AR, which keeps your hands busy in a certain way. So that's why by using HoloLens, I can see the participant in meeting in front of me, and at the same time, I can see data overlaid onto the space of the meeting also. Is that clear?
Okay, thank you. That's, yes, it's clear. That's obviously better than seeing someone and not seeing other participants. Yes. Your study is about presenting financial data, and what are your thoughts about possibilities of presenting technical data?
I mean, of course, this is a very good question, and technical data is very broad, as well as financial data. financial data. Here we talk specifically about valuation data, which is basically the estimation of the value range that a company has and also the possibilities that a company may earn in the following years. So the earnings that can be foreseen. And we target, so this specific type of financial data, as you saw, it was visualized in a stacked area chart. Now, technical data, of course, I cannot give I have to say that this is such a big question, and it's, you know, I think that more than talking about one type of data or another, it's about the complexity of the data that could the amount of, so it could regulate the amount of possibilities in the field of view of the viewer to be seen, in the sense, so what I'm talking about is that HoloLens has a field of view which has certain specifications. So depending on the type of data that you want to overlay with HoloLens, it will be possible or not, because we're not talking about virtual reality where you have 360 around yourself, but we're talking about a viewer that has certain limitations. So to me, it is, so the limitations for these are with regards to the complexity in the data and the amount of data. So these would be the two aspects to think about when talking what type of data is this possible to be used for. Yeah.
Yes, thank you. You pointed out the complexity, and I think all the papers in one way or another deals with the complexity and tries to handle the complexity and help the designers. My question for Professor Stetter, I'm interested in one aspect of your work. You mentioned the design compiler that was developed and that it has a unique capability to create detailed and complex geometry from UML diagrams. And I wonder how is that transfer done, from which this compiler starts, I guess from some kind of templates or layouts?
In fact, it starts with class diagrams. So it's an environment in this design compiler. There's an environment based on UML. It's based on Eclipse. So if you know, Eclipse is a rather famous UML, like say, system, because it's more than just a graphic interface. It's a lot. But based on this Eclipse, there you have all the information about the classes. And you also describe the activity diagrams then. And this is the input for this design compiler.
But what is the basis for creating the geometry? Do you create geometry from scratch or from some layouts or?
No, from scratch. We use like geometry primitives. I mean, this is also what a CAD system does. There also you have certain kinds of geometry primitives like cylinders and so on and so on. And these are defined there. So it's not based on some layouts, but you start, so to say, in an empty space by using geometry primitives.
Okay, so the application creates geometry from primitives from scratch based on the
exactly
UML diagrams.
You have some intersections. I mean, this is similar what also happens in the core of a CAD system, but it's just another way to express it, and it's a way that's open. And for a usual CAD system, you don't see what happens within the core, and therefore it's really difficult to have this information available. And if you look at decision, also then to be able to visualize it, because this is hidden. These are secrets of the CAD systems. But here we have everything. We know what's in there. And I think, especially for this session, that might also be interesting opportunity, because, so to say, nothing is hidden there. Everything is, I mean, it's complex, but it's generally visible.
Yes, it's very complex, and it seems that this is a very huge system to be able to do something like that, obviously.
Sure. I mean, obviously, for each systems, you need to have certain components, you have to have certain modules. So as usual, you need some modular structure to be able to handle it. But our experience so far shows that it's possible. Could I then also ask a question?
Yes, of course.
Okay, great. Or do you have, if this answer is okay for you?
Yes, thank you.
Mm-hmm. Because I also have a question for Jens Brinkmann. I liked it a lot, especially I liked it a lot when you showed the example of the race car. We also develop our race car. The problem there would only be that everything would be red, but that's just beside. What I just question, you talk about design information maturity. And in my thinking, in my mindset, I would rather think about design maturity. So because I was working with Audi, and at Audi, we would jump from red to green if we passed the final test. So there would be some important testings. And as soon as we have the test result positive, then we are green. And even if you all have all the CAD models, if we have real nice information, if it just fails the test, we are red again. So maybe just a short comment, how you see this design maturity versus design information maturity.
It's a good point that you mentioned. So with the complete taxonomy that is not shown in this paper, we have one important aspect or subfacet, which is called the procedural completeness. So I think this passing tests or passing stage gates, or however your organization of your design process is, would be one aspect that contributes. We also realize, based on other relevant publications, that this is not necessarily in sync with the actual design data. So just because, or maybe your data is even more evolved, hasn't passed this stage gate, for example. So that's why we feel that practitioners can potentially better express the status of their part that they are designing, or the piece of information that they are working on, based on this entire taxonomy of 17 subfacets, rather than just focusing on the stage gate approach or similar, having passed a test or not.
Mm-hmm. But this part of your whole aggregation scheme, as I understand, but not shown. Okay, thank you.
Yeah, so that's, as I'm trying to explain, that's just one of these subfacets which would then be aggregated into this overall design maturity status. And yeah, you mentioned the design information aspect. So that is due to the fact that we say you have very different aspects that can apply to if it's just a parameter value, if it's a prose document, or if it's a complex 3D geometry.
Mm-hmm. Okay.
Did that answer your question?
Yeah, yeah, perfectly. Thank you.
Thank you. If someone else have a question between you for each other, you can proceed. We have a question from chat from Mr. Pereira. This is for Ms. Bravo. All participants with HoloLens were observing the 3D model from their perspective.
Okay, hi. So thank you for the question, Joao. So actually, these, well, this is something that I explained in the paper. So we thought precisely that each of the participants in the meeting, so just for everyone to imagine the setup, everyone is wearing a HoloLens on a, we just set it up in a round table. So the idea behind this is that each person has the same point of view. meaning that it's not like having an object, like if it was in the center of the table and each of us has a different perspective, a different angle according to how we are positioned. With HoloLens, every one of us, we have exactly the same view and the same angle of view of the object. We wanted to do these. One of the reasons for that is that certain types of geometries are very descriptive when you look at them, for example, in the front or maybe at 3/4, but maybe in the back, they're not interesting. So depending on where you are positioned in the table, if we would have done it according to the positioning in the table, some geometries might then not be descriptive enough. Thank you.
Thank you. One question for Professor Stetter and Mr. Pottebaum. Could you maybe comment about possibilities of connecting your or integrating or merging your approaches?
Okay. Well, do you want to start or? Because I think there is definitely possibilities. UML and SysML are not so different. It is right now that our compiler can only use UML, but this would be not a major rework. So from this point, I think it would be possible. I think this morphology, as you call it, of intuitive interaction, I think that's a whole other viewpoint, but in my point of view, that could work together well. It's just a question of SysML and UML, and this from my point of view is not so important. I don't know how you see it.
Well, I agree on that. So my perspective is that as far as I understood your approach, I think we are contributing different options. So let's say options how to interact, so to view, to simulate, to interact, to manipulate the models that you are using to then derive certain artifacts out of that. And then there is in between that steps, there is the question how to interact with these models, how to interact with the different configuration opportunities. And that's the phase in which we would like to contribute by structuring the different options that we have there and opening that up. So there are options, but from our perspective, this is too limited at the moment.
Okay, yeah, that's true. But if it's open up, there's no contradictions in there. Yeah. But it's a way. I also think in future there will not be only one solution to the things. There will be many. For example, this system, if you look at wiring problems. So if you have a system like a car and you want to do automatic wiring, it's extremely strong because then the algorithm work very well. If you have complicated class A surfaces of a car body, there are other things like surface modeler which do this better. So I think the answer in the future will be multiple models and then also different ways to interact with these multiple models. And I think the best thing which we can do is not to build walls, but to look for like possibilities, combination possibilities, I would call this.
Thank you. There is a question from Professor Maier to Sebastian Stadler, but unfortunately, I think he's still not present. Am I right, Fanika?
Yes, that's right.
Okay. So we are approaching the end of the session, but anyway, I'm really curious and I want to ask one provocative maybe question for Mr. Brinkmann and for Ms. Bravo. Since you are obviously experts in augmented reality, what do you think, could we in future apply that in any way to enrich the scientific papers and presentations at conferences?
Okay, may I go for this? I actually thought about doing this with the current paper. However, one of the things that we need to take into account is that the practicalities. So today it's possible via a QR code to embed some augmented reality in your paper. But the point is, when you embed a QR code, you need technically to have these so it redirects to a website, and these needs to be up all the time. So everything that goes through AR, or anything that is digital, goes through any type of, in that case, if we want to redirect it to the web, we need to host it for an indefinite period of time. So technically, of course, it's possible, but it's about the sustainability of this. So maybe now that I have the possibility to maybe envisaging these for the future, there could be some kind of possibility that we could embed a link that could be hosted somehow in the design platform. So I think this would be a very interesting possibility for the future, because technically it's possible now. Who hosts this and for how long?
So I absolutely agree with you. I think it's a very similar question to if you're referencing websites, for example, what if they change, etc. Probably there will be solutions how you can capture this augmented experience, not for an indefinite amount of time, but probably for a very long amount of time. I think it also depends on the kind of information that you're sharing. So I think one of the challenges with AR is the hype that everybody wants to use it, and only a few applications, in my opinion, are susceptible to that. But I think definitely in a design conference where people might talk about details of a particular design and share their insights and their new approaches, I see a lot of potential to make it really work and to make it meaningful.
Thank you. That sounds promising, and I think that in future could help and enrich the papers and the presentations, and that way I think we could at least easily understand or quickly be able to understand some concepts in papers and presentations. Okay, thank you very much. It's time to conclude the session. Thank you for all your presentations. Thank you for your discussions. And I think we had a really good discussion and fruitful discussion. Goodbye and see you later.
Yeah, I think we should give a hand to our session chair. Thank you.
Thank you.
Thank you.